Hi there, this is Regina. In this video, I will discuss and apply the rules of graph transformations. Think of f of x as any parent equation, such as y is equal to x squared, y is equal to x, y is equal to square root of x, y is equal to x cubed, y is equal to cube root of x, y is equal to the reciprocal of x, or y is equal to absolute value of x. Here are the rules for graph transformation. You have several ways in which you can transform your original parent equation. You can either shift it horizontally, left or right, and if you shift left, the equation will reflect a plus by the amount you've shifted left, or if you shift right, the equation will reflect a minus by the amount you shifted. Then there is the vertical shift. You can shift up or you can shift down. If you shift up, the function is added to a constant, or if you shift down, there's a constant subtracted from the function. Shifting up and down, the sign does not change, but shifting left and right, you notice that the sign changes. Then there is the reflection. You can reflect in the y-axis or the x-axis. If you're reflecting in the y-axis, there is a negative in front of the x. If you are reflecting in the x-axis, there is a negative in front of the y. Then there are transformations which change the shape of the graph. You have the vertical stretch or horizontal compression. With the vertical stretch, there is a number in front of the function, and with the horizontal compression, there is a number in front of the x value. In both cases, the number must be greater than 1. Then vertical compression and horizontal stretch can also change the shape of the graph. You can think of the vertical compression or horizontal stretch as making the graph a little bit fatter, and you can think of vertical stretch or horizontal compression as making the graph a little bit skinnier. Now, if you are compressing the graph vertically or stretching it horizontally, you put your a value, which is in front of the function for vertical compression, or a value in front of the x for horizontal stretch. The a values in both the cases is between 0 to 1. So I want to caution you about the horizontal transformations. If we are creating point transformation, the best way to remember how to do the horizontal transformation is to reverse the operation that you see written in the equation. And we will do some examples now. So the first one is g of x is equal to negative a half x squared. Our parent equation is y is equal to x squared. The best thing to do here is to create an xy point with the parent equation first, and let's pick negative 2, negative 1, 0, 1, and 2. So we get 4, 1, 0, 1, and 4. Now let's go ahead and look at the transformations here. The negative tells us that this is a reflection in the x-axis, and the half tells us that the y values have been halved. So we know that the x values have not changed at all. So we'll keep the x values, but the y values have been changed. So let's go ahead and figure out a new set of y values. Values right over here, and you can simply go ahead and sketch out a graph. Negative 2 right here. Negative 2 will go negative 2. Negative 1 is negative a half. Let's say it's over here somewhere. Negative 1, negative a half, and negative 2 will go negative 2. And you can see that we have a graph that looks like that. And it'll reflect the transformation shown here. Let's look at this graph here. This is best done by shifting your asymptotes. You can identify the parent function as y is equal to 1 over x. So here's your y-axis and here's your x-axis. And I'm going to create a vertical asymptote here. And I'm going to create a horizontal asymptote here. And this is my graph right over here in white. The transformation is shifting your vertical asymptote 6 units to the right and shifting the horizontal asymptote 2 units to. In other words, x equals 0 asymptote is shifted 6 units to the right. So let's go ahead and show that. Here we have shifted x equals 0 to x equals plus 6. Now y equals 0 asymptote is going to be shifted down by 2 units. So let's go ahead and do that right there. And then you can create another graph around your new asymptotes. So this is your sketch of the transformed graph. You must keep the original x and y axis right where it was. This one here, there's a list of transformation. Negative means reflection in the x-axis because the negative is in front of the function. 2 means all the y values have been increased by factor of 2. Plus 1 here means the entire function has been shifted 1 unit to the left. Plus 3 means the whole graph has been shifted 3 units up. The easiest way to do this one would be to create again your parent equation, which is y equals x squared. Create yourself some points, -2, -1, 0, 1, and 2, and we have 4, 1, 0, 1, and 4. Let's go ahead and look at all the transformations on the x. And remember, with the horizontal transformation, we have to do opposite of what appears in the equation, so we will go ahead and x -1 here and create a new set of x values. We create a new set of y values, and y value is -2 times the old y plus 3. Sketch out your x and y axes here, plot out the points, and you'll get your transformed value. So you can see that the graph has been shifted 1 unit to the left and 3 units up. We can just draw a nice smooth curve as best as we can around this one. Alright, the final one here, this one here, we have h of x is equal to square root of -2x minus 3. This is where we see a transformation on the x, and remember, anytime you see something on the x itself, you want to do the reverse. So instead of multiplying x by 2, you will multiply x by 1/2. This would be a horizontal compression. So this graph would be a horizontal compression because of 2 here, and negative in front of x means reflection in the y-axis. -3 means shifting the entire function down, vertically down by 3 units. So the easiest way to do this is again identifying our parent function where it is square root of x. And let's go ahead and create some points. Let's say 9, 4, 0. Square root of 9 is 3, square root of 4 is 2, 0, and the transformation on the x would be multiply the x by -1/2. Because it's a horizontal transformation, we want to do opposite of what's given in the equation. So, and the y transformation is going to just be -3, and that's your graph right there. And you can see that the transformation works. The parent function was over here. We did indeed reflect it in the y-axis. We did indeed shift it down by 3 units. And we did indeed change the shape of the graph here. Okay, now here's an interesting problem here. You are told that there is a function and the y-intercept of that function is -2. You're not told what the function is. But you are asked, what is the y-intercept if that function had the following transformation? So you can create any function you like as long as the y-intercept is -2, 0, -2. Look at the transformations here. The negative in front of x tells you that this whole graph has been reflected in the y-axis, which essentially leaves the y-intercept unchanged. But then the negative in front of the function tells you that the graph has been reflected in the x-axis. So this whole graph has been reflected in the x-axis, which makes your y-intercept 0, 2. So in this case, your new y-intercept would be 0, 2. In the second one, the graph has been moved down, shifted down by 2 units. So your y-intercept is going to shift down by 2 units, and your new y-intercept for the transformed graph would be 0, -4. The new y-intercept is 0, -4 on the transformed graph. Okay, what if you were given a graph that looked like this, and you were asked to perform this transformation here? So what we notice is two things here. That negative in front of x means it's reflected in the y-axis. And watch out, the 1/3 in front of x means that the x is stretched out by a factor 3. So we have to multiply all of the x values by 3. So if we created some old points here, -3, -2, -1, -2, 1, 2, and 3, 0, and each of the x values has been multiplied by -3. Y is equal to -3 f of x. And in this case, the transformation is not on the x formed, so we don't have to do anything with the x. For transformation on the y, we do not have to reverse any operation at all. So we simply take the y values and multiply by -3. So let's go ahead and plot this. And this is a graph that reflects horizontal stretch by factor 3 and reflected in the x-axis. So that ends my video. Thank you very much for listening. Goodbye.